Okay, for question number 71. The diagram shows the trapezium ABCD, in which A is the point 1, 2, B is the point 38, and D is the point 54, as can be seen there. That's a trapezium. Angle ABC is equal to 90 degrees, and AB is parallel to DC. I can find the gradient of AB if I want. Okay, so the gradient of AB is going to be y2 minus y1 over x2 minus x1, which is 8 minus 2 divided by 3 minus 1. Okay, so over here, 8 minus 2, 3 minus 1. And in a moment, it's going to become clear to you why I want to find this gradient so much. So the gradient is 3, actually 6 divided by 2 is 3, yes. So by finding this gradient, and because this line is parallel to this one, I can find the gradient of this line if I want. Okay, so what's the gradient of DC then? So DC has the same gradient as 3. And because I want to find the coordinates of C, I can find the equation of this line. So the equation of DC is going to be equal to y is equal to mx plus c, which is 3x plus c, because the gradient is 3. There's a point here, 5, 4, that can be substituted in here to find the equation, the value of c. The point is 5, 4. 4 is y, so 4 is equal to 3 times 5, which is 15 plus c, and then c turns out to be minus 11. So the equation is then 3x minus 11. That's for DC. I want to find the equation of this line as well, and this is perpendicular to this line. Therefore, the product of their gradient is going to be equal to minus 1. So the gradient is 3 here for this DC, and hence the gradient of this line is going to be minus 1/3. So I can find, first of all, the gradient of BC. BC's gradient is minus 1/3, because we know that M1 times M2 is equal to minus 1, that if the lines are perpendicular. So therefore its equation is going to be equal to y is equal to minus 1/3 x plus c. And now on this line there's a point here, 3, 8. X is 3, y is 8. So I can substitute y for 8, and I got minus 1/3 times 3 plus c, and then c turns out to be, this is minus 1 and 9. So c is 9, therefore the equation of line BC, okay, is going to be equal to y is equal to minus 1/3 x plus 9. I got this equation, that equation, that can be solved simultaneously. So if I solve these two simultaneously, so what I'm going to get? I'm going to get 3x minus 11 is equal to minus 1/3 x plus 9. So 3 times 3x is 9x, minus 33 is equal to minus x plus 27. You cross multiply on both sides. 9x plus x is 10x, and I can say 33 plus 27 is going to be equal to 60. That means x is equal to 6. So if x is equal to 6, I can easily find y. Y is going to be equal to minus 1/3 times x, which is 1/3 times 6, okay, plus 9. So that means I got then minus 2 plus this is going to be equal to my 9 minus 2 is 7. So the coordinates of C is then 6 and 7. Here we are. And now we're going to move on. The point E lies on BD and is such that the area of A of CDE to the area of CDB is 1 over 4. Okay, the area of CDE to the area of CDB. This is 1/4 of that. This small here is 1/4 of the whole area. Okay, so if this is 1/4, this is 1, this should be 3. So I've got a ratio here, and I can use ratio theorem. So by ratio theorem, we want to use ratio theorem to find the vector OE. Then I can find the coordinates of E. So I'm going to say OE. It turns out to be like this. So this is E. This is 1. This is 3. Because it's 1/4, isn't it? So and I've got D and I've got B. Therefore, OE is equal to 1 times OB plus 3 times OD, vector OD and vector OB, divided by 1 plus 3, which is 4. So what is OB? OB has been given as 3/8 in the question. So I got then 1/4 into 3/8, all right, plus 3 times OD. Okay, so that means 3/4. No, hang on. What I'm going to do is 1/4 is outside, and I'm going to say 3 times OD. So OD is 5/4. Therefore, I've got 1/4 into 3 plus 3 times 5 is 15, is 18. Then 8 plus 3 times 4 is 12. 12 plus 8 is 20. That means 3 plus 15 is 18, yeah. So 18 divided by, let me see, turns out to be 4.5. And then this is 5. So I've got the vector OE, and therefore E is going to be equal to 4.5 and then 5. Now from here I can find, let's check this out properly, because it's 1/4 of BD. You're out. Okay, so 1 is to 3, 3 OD, and OD was 5, 15, and then 12 plus 3, and this thing is, okay, that's fine. Okay, I'm happy with that. Now we want to read further. The point F is such that CDFE is a parallelogram, as can be seen there. CDFE is a parallelogram. Find the coordinates of F and the area of the parallelogram CDFE. The coordinates of F. Now I can say that FE is equal to DC. So I can find DC. So let me just move this a little bit up here. Find DC, which is equal to DO plus OC. And now DO is minus 5 minus 4. Okay, plus OC, and OC is 6, 7. So this is then 1, 3. So that's DC. Now DC is parallel to FE, so FE also, which is equal to FE. And what is FE? Now FE is FO plus OE. And FE is 1, 3 is equal to FO, all right? So FO plus OE, and OE was found to be 4.5 and 5. So this can go on the other side, and I've got then FO is equal to 1 minus 4.5 is minus 3.5, and then 3 minus 5 is minus 2. Therefore, OF is going to be equal to 3.5 and then 2. Hence, I found F as 3.5 or 3.5 and then 2. Here we are, done. Now we want to find the area of the parallelogram, so we're going to use Modulus Method. Okay, so the area of the parallelogram, FECD, FDCE, whatever, FECD. So this is half. To take the first coordinate, I'm going to take 5, 4. Then I'm going to take C, which is 6, 7. I'm going to take E, which is what we found is 4.5. And then 5. And then this one is 3.5, which is F. 3.5, 2, and we end up with 5 and 4 again. So let's do the multiplication. So I've got then half into modulus of 35 plus 30 plus 9, and then 35 plus 30 plus 9 plus 3.5 times 4. On my calculator I'm getting 88. Take away the y coordinates. 24 plus 4.5 times 6, times 7. Okay, plus 3.5 times 5. Okay, and then plus 2 times 5, which is 10. Oh, here, hang on. 24 plus 4.5 times 7. Okay, plus 3.5 times 5. Okay, plus 2 times 5 is 10. 83. So I'm looking at half times the modulus of 88 minus 83, which is then 5. So that's half times 5. The area turns out to be 2.5 units square. Here we are, done. Take care.